calculus kids. This is Dr. Callahan with Week 2 Tuesday. I hope you guys had a good week. Welcome back to Week 2. Go ahead and pause the video and answer the following 3 questions for your warm-up. All right, let's go ahead and create the assignment for this week. Keep in mind that week 2, Monday is right here. You have the guided notes, you have the assignment. You got to view the assignment to be marked present. And then, of course, you need to upload the assignment if you have completed this item. Now, you don't have to upload it every single day, but if you want to turn it into me when you guys show up on January 19th, which is next Tuesday, that's fine as well. I am going to be updating your grades today with the Max Excel with week 1, and then also the AP College Board quiz, their first quiz from week 1 Wednesday. So check out for those 2 new grades. That's going to be on Infinite Campus. I'll also go ahead and post it onto MS Team with your student IDs. So it's just as if I'm printing it out, and then you just kind of like look at it, and it'll be secure and confidential as well. And so with that said, let's go ahead and create the assignment for week 2 Tuesday. So week 2 Monday, we talked about the beginning of the area underneath a curve. And today we're actually going to use 3 different techniques to find the actual area underneath the curve. You did that with like the Reiman sum, like remember with the sigma notation, with the I to N, with the formulas. But today we're going to do something a little bit more specific with areas and how the different techniques that we can find it with areas. So week 2, Tuesday. And today we're going to find calculus AB semester 2, calculating. I should put techniques to calculate. Area under a curve. Okay. So your instructions for today is to go ahead and watch the video. It should be equal to 45 minutes of instruction. If you have any questions, my email is right there. There are 2 links that you need for this class. The first one is the YouTube channel. The second one is the Google Doc. And as always, your hard copies are outside my door from these hours. You guys are the second column, and you should be logging on for this class between 9:20 to 10:05 every day. I usually have the videos posted the day before, a day earlier, just because sometimes I have students that have something or somewhere to go between that time frame. So that way you're not marked absent, and I don't have to go back and change your attendance in case you need to check in like the day before. So that's totally fine. And as always, it's always due by 3:30 p.m. the day that it is assigned, and I'm just going to assign it. All right, so I want to take you guys to take a look at the guided notes for today. So week 2, Tuesday, there's actually only 2 pages. I know, 2 pages of guided notes. And I mean, very different than what I usually have before. So the first one is these 4 examples, which we're going to go over in class. And the second one is a video guided note of 4 different examples that you can go ahead and go over as well. So I'm going to go ahead and just copy this over to a PDF. So that way you guys can go ahead and print it out in case that's something that you need to do. And if you don't have a hard copy, but you don't want to use up all the ink from your house, you can just print out maybe the 3 pages for today specifically. Okay, so let's go ahead and save this. For week 2, Tuesday. And save. So then I'm going to go ahead and attach it to the MS Team assignment. So I'm just going to put guided notes. Actually, no, I'm just going to attach it. I don't need to put that. There we go. All right, so there you have your guided notes as well. Okay, so with that said, let's go ahead and get started with today's stuff then. All right, so last time when I saw you guys, we did a practice with the, you would have had a whiteboard, but you had this template that you were supposed to practice with a series of questions of integration. And I also showed you guys how to find the definite integral, which is like the area, like something like number 2, for example, where you find the integration of 8x cubed minus cosine x dx, and then you plug in the upper bound, and then you plug in the lower bound, which is 0, the upper bound is pi, so 3.14, and then you subtract the two, and that's actually the calculating the area underneath the curve of this function right here. So that's what we did last time. And so then today, this is a breakdown of we're going to be talking about. Our notes today is going to be on the left, right, midpoint, and trapezoidal Riemann sum. So that's what we're going to be working on with 4 different examples. And then, of course, afterwards, you guys have 4 other examples that you can practice with on your own. After that, I have a pause notes right here that I would like you guys to read. So this is the link right here. So if you go ahead and click on it, it takes you to this part right here, where he kind of gives you another explanation breakdown of how to go about finding the left and right Riemann sum. And so you can go ahead and read this. And his notes are somewhat similar to mine, but maybe with a little bit more information. And then once you're done with that, you could do some practice problem, which is number 5 right here. So if you type that up, it's going to take you to this link right here, and there are 4 questions also with solutions on it. So it says for problems 1 to 3, you need to find the right, left, and then the midpoint Riemann sum using a rectangle. And then if you're not sure, if you can click on solutions, it does kind of give you the breakdown of how to go about calculating that. So just some additional practice. All right, so with that said, let's go ahead and get started. So we're going to start off on this page right here. Okay. So for the first example, you are to find the left Riemann sum for the function of y equals x squared. So first thing you want to do is you want to ask yourself, what does y equals x squared look like? Well, I know that this right here is a parabola. So most likely that parabola, I know that at 0, and if this is 0, it looks something like that. So if you look at the interval, my interval is from 0 to 2. So really, I'm just kind of looking at maybe that part of the parabola. So if I were to go ahead and draw this, I'd probably just draw something looking like this. Okay. And then what you're going to do with this is you're going to find rectangles. You're going to draw rectangles, and this is the left Riemann sum. So when you draw your rectangles, you're going to draw your rectangles starting on the left side, and this is the left side right here. So here's my point. There's my rectangle. Okay, then again, you're going to start from the left side at the curve of the parabola, straight, second rectangle. Again, third rectangle, and it says with 4 sub-intervals. So what that means is you want 4 rectangles. There we go. So now that I have my 4 rectangles, I need to figure out how do I find the area of each rectangle. Well, when you have a rectangle, remember it's always going to be the base, which is right here, the bottom, times the height. Okay, if you take a look at the base of each of these rectangles, notice they're at the increment of 0 to 1/2, so that's a 0.5, 1/2 to 1, so that's another 0.5, 0.5, 0.5. So my base is going to be 0.5. It's consistent and it's not going to change. But what is going to change is going to be the height, because the height is going to be right here, okay, which is also the y value. So the height also looks like the y value of your function. So if you're going to find the y value of something, you don't have the y value that's given to you, but you do have the x value. So you can do like f of 0 for the height, f of 0.5 for the y value height, f of 1, f of 1.5. And if you look at the 0.5, 1, and 1.5, it is the height of the left side of the rectangles. So that's the height of 0.5, height of 1, height of 1.5. And notice I didn't use 2 because that would be the right side, but we're focusing specifically on the left side Riemann sum. So that's what I can do. All right, so then to find the height of the first rectangle, I would do f of 0, height of the second rectangle, f of 0.5, height of the third rectangle, f of 1, and the height of the fourth triangle, f of 1.5. All right, so let's go ahead and add everything together. So your first area, second area, third area, fourth area. So for your first area, remember it's base times height. So your base is going to be 0 times the height, which is going to be f of 0, plus base is, I'm sorry, it's not 0, base is 0.5, totally my fault, okay? 0.5 times the height of the second rectangle, which is f of 0.5, plus 0.5 times the height of the third, so f of 1, plus 0.5 times the height of the fourth, which is f of 1.5. Now you want to go ahead and grab your calculator and then calculate, well, what is f of 0? F of 0 is going to be 0 squared because f of x is x squared. So then f of 0 is just 0 squared. So that's just going to be 0. So your first one is just going to be 0 times 0.5 plus f of 0.5. Well, what is f of 0.5? That's just 0.5 squared. So 0.5 times 0.5, and that is going to give you some number. So I actually didn't grab a calculator with me, so give me a second. That's going to give you 0.25 plus 0.5 f of 1. So f of 1 is going to give me 1 squared. So that's just going to be 1 plus 0.5 times f of 1.5. So that's just 1.5 squared, which is 2.25. All right, well, let's go ahead and multiply this out. 0 plus 0.75 plus 0.5 plus 1.125. All right, now you want to go ahead and add everything together for the area because it's 4 rectangles of this area under the Riemann sum. And altogether, your area is 1.75 unit squared. And then just keep in mind that this estimation, or this really is an estimation of the area, and it is a underestimate. And the reason that it's an underestimate is because if you take a look at your Riemann sums here with the left Riemann sum, notice like this little green, or excuse me, no, it's blue, let's do green. This little space right here, these little green spaces are undervaluations because your rectangle is not going all the way to the top of the curve. So you do have a little bit of room for error. So this really is like a smaller area than what the actual area is. Now, if you were to find the actual area, you will probably do the integration of x squared between 0 to 2, and that will actually give you a complete area of what it will be. So if I were to go ahead and do that, you would just go ahead and do the power or the reverse of the power rule. So 2 plus 1 equals 3 divided by 3. So then what you're going to have here is that you're going to have 1/3 x to the third plus c. And then you're going to go ahead and plug in, well, we have to find the c value. You plug in the 2, plug in the 0, and then subtract the 2 from each other to find the actual area value. But for the purpose of this one, your Riemann sum is 1.75 using the left Riemann sum. Okay, so now that we've done the left one, let's go ahead and try the right one. Okay, so once again, we're going to draw the parabola, which looks something similar to this. And notice that this one, we're going to do the right Riemann sum. So you're going to start off on the right side with 4 rectangles. So I'm going to start off on the right side, and I'm just going to draw my rectangle to the curve. Okay. Right here. There we go. Here's my second rectangle, third rectangle, fourth rectangle. Okay. And so then my area, remember, for your rectangle is base times height. And so your base is always just going to be 0.5 because that's the interval. And in case in the future you have something, let's say the interval is between a 4 and let's say a 12, and you're doing 4 sub intervals, and you're like, how can I go about finding the base in between them? Well, what you can do is you could take just 12 minus 4, which is going to give you an 8, divided by the 4 rectangles, which is going to give you 2. So what that means is that you're going to have a space of 2 in between each of those, and that's what you can do later on. This one's pretty simple because between 0 to 1/2, you know it's 0.5, but in case it doesn't start at 0 for future questions, that's how you will find the intervals in between them. So then looking at this here, let's find the height, okay? So your height of this is going to be, you're going to start on the right side, f of 0.5, f of 1, f of 1.5, and then f of 2. So notice here your height's a little bit different. And then of course, you're going to be plugging this into the f of x function, which is x squared. So then 0.5 squared, we calculate that before. That's going to be 0.25. 1 squared is just going to be 1. 1.5 squared is 2.25. And then 2 squared is just going to be 4. So these are all the values for your height. And I can go ahead and highlight it for you guys. Okay, so then let's find the area of these. Area is going to be area 1 plus area 2 plus area 3 plus area 4. So the first area is going to be your base, which is 0.5 times the height, 0.25. Area 2 is going to be the base, 0.5 times 1. Area 3 is going to be the base, 0.5 times 2.25. And then lastly, the fourth area is 0.5 times 4. Okay, so then as I look at this, I'm going to have 0.5 times 0.25. You're going to have 0.125 plus 0.5 plus 1.125 plus 2. And if you go ahead and add everything together, you should have 3.75 units squared. And take a look over here. Do you see the little green areas right here that's above the rectangle? Those are going to be an overestimation because you're going above the curve. So just keep in mind that even though that you have this, the 3.75 is an over. estimation on the area under the curve for y equals x squared. All right, so then let's go ahead and take a look at the midpoint Riemann sum. For the midpoint Riemann sum, I'm going to use a different function, but it's going to be very similar. And for this one, take a look at the function itself. You have negative x squared plus 5. So what that means is that if you think about it, if it is going to be an x squared, it is going to be a parabola. Oops, I don't know why I put a square there. Let's give it that. Okay, so if it's going to be a negative x squared, you know it's going to be a sad face parabola. So then if it says plus 5, that means that if you're to draw this, you go up 5, 1, 2, 3, 4, 5, draw your dot, and that's a sad face parabola looking something like this. And if this is going to be between 0 to 2, this is 0, 1, 2. Most likely you're looking at this little figure right here for your area. So then I'm going to draw mine and look something like this. And it's going to be between 5 rectangles because it's 5 subintervals. So what you're going to do is, since it's between 0 to 2, you're going to do 2 minus 0, which is just 2, divided by 5, and that's going to give you a 0.5. So that tells your base is going to be spaced at 0.5, or say 0.4 sections or units for each of the bases. So here's what I have. 0 to 0.4, that's your first one. 0.4 to 0.8, that's your second one. 0.8 to 1.2, 1.0 to 1.6, 1.6 to 2, and then you stop right there. Okay, so then as I'm drawing the rectangles for this, you will have to draw the rectangle at the midpoint. So what's the midpoint between 0 to 0.4? Well, that would be a 0.2. What's the midpoint between 0.4 to 0.8? That's going to be a 0.6. What's the midpoint between 0.8 to 1.2? That will be a 1. And then 1.2 to 1.6 will be a 1.4. And then 1.6 to 2, that will be a 1.8. Okay, so those are the midpoints. And then from there, you're going to be drawing your rectangles at those midpoints. So there's my first one. And then if I were to find the area of this rectangle, remember it's going to be the base, but remember your base is going to be 0.4, but that 0.4 you're going to be multiplying to all 5 of those rectangles, okay? And that's going to be your first rectangle, so area 1. And so how do you go about finding the area of a rectangle if you're looking at the midpoint? Well, your height for your rectangle will have to be the height at the middle or the midpoint. So you're like before when we did the left and right Riemann sum, you would do f of 0 for the left, f of 0.4 for the right. But because you're doing the midpoint, your midpoint is 0.2. So we're going to do f of 0.2. Then for your second rectangle, there's your second rectangle. Your height is still 0.4. So I just put 2 over 5 because remember 2 over 5 is the same thing as 0.4. We're just going to multiply it to all of them here, all 5 rectangles. Your height in this case is going to be the middle, which is going to be 0.6. So f of 0.6. And then let's take a look at the third rectangle, which is right there. The midpoint of the rectangle is 1, so your height will be f of 1. And then your fourth rectangle, the midpoint is 1.4. Fifth rectangle is 1.8, and so we're just going to add the rest along with it. Let me erase this part here. And notice your 2/5, or which is 0.4, you're going to be multiplying that to everything, to the 5 rectangles. All right, so then let's go ahead and find the height of this. To find the height, you will have to do f of x equals negative x squared plus 5. It might be easier if you use the second calc option. So that way you don't have to keep systematically plugging this in. So graph negative x squared plus 5 on your graphing calculator or Desmos. And then when you do the second calc option, make sure you put the value for 0.2, 0.6, 1, 1.4, and also 1.8 to determine the height of your midpoint Reiman sum. So then when you do that, you should have the height of the first rectangle is going to be 4.96. Second rectangle is 4.64. Third rectangle is 4. Fourth rectangle, the height is 3.04. And the fifth one is 1.76. So you could go ahead and take those individual heights and multiply by 0.4 for the base, or you could just do PEMDAS, add everything together in the parentheses, and then multiply at the very end. So let's add everything here together and multiply it, which will give you a 7.36 area. And this area is actually more accurate than, I would say, the left and then also the right. And the reason for that is because if you take a look at the way that this is drawn, when you draw the midpoint Reiman sum, you do have a little bit of a undervaluation, but then you're also balancing that with the overvaluation. So it kind of cancels each other out. So this is a more accurate. Your left is always going to be an underestimate, and your right is always going to be an overestimate. And these are actually the areas of the y equals negative x squared plus 5 if you're to find the left Reiman sum and also the right Reiman sum. But yeah, so this is how we'll do the midpoint. All right, so let's go ahead and move on to the next part. Okay, so let's use the same one and find the trapezoidal Reiman sum. So once again, this is going to be your graph, okay? And you know that your base is 0.4 because that's how it's sectioned off, okay? But the problem with this is that you're going to have to kind of look at this a little bit sideways as a trapezoid. So your trapezoid, a lot of time people kind of envision trapezoid looking something like this, right? But you also need to realize a trapezoid can also just be a rectangle with a triangle like that, okay? Now, if I were to rotate this over, that's what it will look like with a trapezoid. And if you take a look at your graph here, if I were to write 5 trapezoid, do you see how the incline of this part here with this graph fits the curve a lot better? And the area of a trapezoid is going to be 1/2 base 1 plus base 2 times height. So your base 1 is going to be this part right here. That's your first base. Plus base 2, which is this part right here. That's your second base. Your height is going to be this part right here. And I know you're like, but wait a second, you're now switching it up. I am technically switching a little bit because you're rotating your trapezoid over, but just keep in mind that your base is 0.5 or 0.4. Okay. Now, if you don't feel comfortable with the idea of having this, the base and the height switched over, you can actually re-switch them back. You can say that the height is actually the base, which is 0.4, and then just think of it as height 1 and height 2. It's the same thing, same formula, just changing the terminology a little bit, okay? All right, so then for your first one, your height 1 is going to be f of 0, And your height 2 is going to be f of 2 over 5, which is 0.4. And so if I'm going to find the area of the first one here, I will go ahead and do area 1. I'll do 0.5 base, which is 0.4, height 1, so f of 0. And let's go ahead and make sure you guys have your second calc in there. I don't have mine in there yet, but I will. So negative x squared plus 5. And I don't like the fractions, so I'm going to rewrite this. So that my first one 0, 0.4, and then this one's 0.8. Next one is 1.2, 1.6, and then 2. Okay. So then height 1, which is going to be f of 0. So do your second calc, which is going to be 5, plus height 2, which is going to be f of height 2 is f of 0.4, and that's going to give you a 4.84. Okay, and remember your first area is going to be the 0.5 times your base times your height 1 plus height 2. Okay, your height 1 is going to be f of 0, height 2 is f of 0.4. So there you go. Plus, let's do the second area. If I were to go ahead and draw the second area here, this is my trapezoid. Okay, so then again, remember it's going to be 0.5 times base, height 1 plus height 2. So then I have 0.5 times the base, which is 0.4. Height 1 is going to be this height right here, so it's the f of 0.4. Well, f of 0.4, as we found before, is 4.84, plus height 2. Height 2 is going to be f of 0.8. So that's something we haven't calculated yet, but I'm going to go ahead and do that right now. So 0.8, so that's going to be a 4.36. Plus, let's go on to the next one. So I'm going to draw my rectangle right here to here. Here's my trapezoid. Okay. So my third rectangle or trapezoid is going to be 0.5 times base, which is 0.4. So 0.5 times 0.4. Height 1 plus height 2. Your first height here is going to be f of 0.8, which I found before was a 4.36 plus f of h2. So f of the new height is right here, and that's 1.2. So I'm going to do my second calc. 1.2 is going to give me a 3.56. And that makes sense because your height's getting smaller because you look at it, the curve is getting lower and lower. So that makes sense. So then I'm not done yet because I have to keep going with this and go on to the fourth trapezoid. So from this point to this point, draw your trapezoid. There you go. So the area of my fourth trapezoid is going to be 1/2 base times height 1 plus height 2. So that's going to be a 0.5 times a 0.4. Height 1 is right here, and that's f of 1.2. From the last one, we found that was 3.56 plus height 2, which is this part right here, and that's 1.6. So f of 1.6. And if you do the second calc on that one, that's going to give you a 2.44 plus, oh my goodness, we're almost there. We're almost to the end. We're going to add the second, or excuse me, the fifth area, which is 0.5 times base times height 1 plus height 2. So that's a 0.5 times the base, which is a 0.4. Height 1, so let's draw my trapezoid. So there we go. My height one is going to be f of 1.6. And f of 1.6 is going to be 2.44 plus height 2, which is this part right here. That's f of 2. So do your second calc. F of 2 is going to be 1. All right, so this is a lot. Let's go ahead and add everything together and also multiply by 0.4 and then 0.5. So then looking at this part right here, and have 0.5 times 0.4 is going to give me a 0.2. Okay, so this part right here is going to be a 0.2 times 5 plus 4.84. This piece right here is going to give me a 9.84. Plus, let's take a look at over here. 0.5 times 0.4 is a 0.2 times 4.84 plus 4.36 is going to give me a 9.2. Now let's go into the third area. 0.5 times 0.4 is 0.2. 4.36 plus 3.56 is going to give me a 7.92. 0.5 times 0.4 is a 0.2. However, 3.56 plus 2.44 is going to give me a 6. Your fifth area is going to be a 0.2 and then 3.44. So you can either do it this way or you can even do 0.2 times all of these numbers added together, or you could do them separately, whichever floats your boat. So 9.84 plus 9.2 plus 7.92 plus 6 plus 3.44 is going to give you a 36.4. Times that by 0.2, your area is 7.28 units squared using the trapezoidal Reiman sum. Okay, so if you would like to practice with this, you can go ahead and do the left, right, and middle trapezoidal, or sorry, left, right, and middle Reiman sum using the function of y equals negative 2x plus 5. If you're interested in doing that, go ahead and pause the video and do that. So here we go. If you were to do that, this is what you would have. Now, we did find the trapezoidal Reiman sum, and what was 7.28. If you were to do the left Reiman sum, it will be 6.48. If you were to do the right Reiman sum, that will be 8.08. If you were to do the midpoint Reiman sum using this function, it will be 7.36. Our trapezoidal Reiman sum actually falls in like right in between here. And this is an actual more accurate estimation of the area. All right, you guys, if you would like some more practice, I would suggest that you get started with these questions right here. They're also from your textbook. And so this one asks you to do x squared plus 2. And from that, you're doing the left side, right side, midpoint, and the trapezoidal Reiman sum. And if you need a video to kind of take you step by step through this, there's a tiny URL on your guided notes. And that's basically it for today. So as always, stay safe and healthy, and I will see you guys tomorrow. And check Infinite Campus because your grades are updated.